Hello everyone. Today our experiment is meter bridge. Using meter bridge, we are going to determine the specific resistance of the given wire. So actually let us see the principle on which meter bridge works. Meter bridge works on Wheatstone bridge principle. What is that Wheatstone bridge principle you have done in theory? If R1 by R2 is equal to R3 by R4, where R1, R2, R3, R4 all are resistances. So here I have written the formula X by R is equal to RL1 by RL2. This R is the resistance per unit length of the meter bridge wire. So first of all, let us see what is the meter bridge. This is called the meter bridge. It has two gaps, left gap, right gap, and it consists of 1 meter length of wire, and just by the side of it or beneath that you have a scale fitted, and you have one more winding screw here. So now this is a nichrome wire whose resistance you are going to determine. Now this is the unknown resistance X we are calling, and known resistance which you are applying from the resistance box that is connected here. Now what we are going to connect from the midpoint, from this binding screw, I shall explain soon. So that is about meter bridge. Now this 1 meter bridge wire has some resistance. That resistance per 1 centimeter, I am taking it as a small r. Don't confuse that small r as a radius. Radius of the wire is also determined, taken as r only here. That we will see later. But just for you, to make you understand how you got this formula, I am explaining this R. This R is the resistance per unit length of this meter bridge wire. So, for 1 centimeter, if R ohms is the resistance, for L1 centimeters, how much it will be? L1R ohms. So, instead of that, what you have learned from theory, what is that? R1 by R2 is equal to R3 by R4. Here I have written X. In place of R2, I have written R. And in place of R3, I am writing it as RL1. Instead of R4, I am writing it as RL2. RR cancels. So this becomes X is equal to RL1 by L2. That is how you got that formula. So here X is equal to RL1 by L2. Using this formula, we are going to find the resistance of the given wire, which you have connected nichrome wire. Nichrome is an alloy. Okay. So this you have connected in the left gap of the meter bridge. So the connections are done as per the circuit diagram here. X is the unknown resistance. RB is the resistance box. RB is the resistance box. And what is this HR? HR is this 5K. Okay, 5000 ohms. High resistance. Okay, this helps us to protect this galvanometer from damage. This galvanometer is a very sensitive device. There is every possibility if more current passes, it gets spoiled. So to protect it, we have connected this high resistance in the circuit. And this is the key. So now what are the connections? Battery. Battery is the positive side of the battery. That means the red one is connected to where one end of meter bridge. This one. So this one. So from positive to meter bridge slot, one binding screw, one end of meter bridge slot. And the other end is connected, negative of the battery is connected where key. So I'm just putting the dot. That means plug is inserted. Negative is connected to key. The other end of key is connected to the other end of meter bridge. Here. Negative is connected to the other end of meter bridge. This is called L clamp there. Now, this is the middle of the binding. One more binding screw is provided, which we are calling it as C. And from C, what is connected? HR means high resistance. And high resistance is this. It has two binding screws. So from the middle, I have connected this high resistance. And the other end of high resistance is connected to galvanometer, positive, red one. And the other end of galvanometer is connected to J. This is called jockey. So this is jockey. Now all the connections are done. Now we have to do the experiment. Now just check whether all these plugs are tight or not. Now everything is ready. After that, you just take out 1 ohm. That means we are starting our experiment with 1 ohm. This is where resistance box. Okay. Now, to check whether your connections are correct or not, what you have to do is, this is called jockey. So this is the metal contact. You just press on one end of meter bridge wire. Now, when you press at one end, see, you have galvanometer like this, 0, 30 or 20, whatever it is. So you should get the deflection to one side. Now, if you press it to the other extreme, you should get the deflection opposite direction. Then only the deflections are the connections are correct. Otherwise, check where you have done the mistake. Now, when that is the case, okay, we have applied 1 ohm resistance in the resistance box. We got the deflections in opposite directions. That means our connections are correct. Now, don't drag it on the meter bridge wire, but check at various points. See, when you get the deflections in opposite directions, at one point, it is sure that what you are going to get what deflection? 0 deflection. Okay. So, you have to catch that point. That is called null point. So, I'm just checking at various points where I got the first one. I'm getting say 32.8 for example. Now, what is L2? From the starting point of the meter bridge to 32.8, what is this wire? This wire, I'm calling it as unknown resistance wire. I don't know the resistance. What is my aim in doing this experiment? Firstly, to determine the specific resistance of the given wire. This is the given wire, nichrome wire, I said. So, in order to find the specific resistance, first I should know the resistance of this given wire. So, my first attempt is to find the resistance of this wire. This is unknown resistance. But I am sure how much resistance I am applying from the resistance box. So, what is this? This is the known resistance. This is the unknown resistance. So, I'm just testing at various points on the meter bridge wire. At one point, at the same time, I'm concentrating on the galvanometer. So, earlier when I tested on one end of the meter bridge wire, I got to one extreme of galvanometer deflection. When I tested on the other end, I got to the other extreme. So, like that, if I go on checking, at one point, what deflection I'm getting in the galvanometer? 0 deflection. So, that is from the starting point A to this point where I'm getting 0 deflection. This reading, I'm taking it as how much? How much I have written here? L1 centimeters. What is the total length of the meter bridge wire? 100 centimeters. So, from here, where I am getting 0 deflection, that is L1 centimeters. So, when I have applied 1 ohm, where I got 0 deflection? 32.8 centimeters. Now, the rest, should I measure? Not necessary. 100 minus L1 is L2. Okay, on the scale, if you measure also, it will be the same. Or if you do just a simple calculation, what is 100 minus 32.8? 32.8 I have written here. 9 minus 2, 7. Here, 67, correct only? Okay. 67.2. Okay. First reading is over. Now, that's all. For next reading, you apply 2 ohms. You keep this plug back in the 1 ohm socket. Just keep the 2 open. And again, test on the meter bridge wire where you are getting 0 deflection. So, note down those readings here. Now, what is X is equal to? X is equal to 1 ohm into L1. What is L1? 32.8 divided by 67.2. What is the unit of X? Is resistance, no? So, what is its unit? Ohms. What is the unit of resistance? Ohms. So, like that. Now, next reading, keep these 2 open, 3 ohms. Just take 3-4 readings like that. They will mention how many number of readings you have to take. 5 or 6 readings you take. Average of all these 5-6 readings which you have taken in the last column gives you what? Average X. What is X? Ohm. Unit of X is ohm. But what is X? Resistance. Whose resistance? Ever resistance are they? Resistance of the given wire. Which you call it as what resistance? Unknown resistance. Okay. So, unknown resistance you have taken. 5 or 6 readings you have taken. Now, here I have written average X. How do I write average? How do I calculate average? 1, 2, 3, 4. Total sum of all readings divided by number of readings. Depends on how many readings you are taking. So, you will get average X like that. That many ohms. Now, L. What is L? Length of the given wire. Which is the given wire? Meeku ichina wire edi? Idi kada meeku ichina wire. So, L is length of the wire. What you will do is, I'm just taking it out. Okay. You stretch it. And it should not be like this. If you have like this, length will be incorrect. So, stretch it straight from starting 0 to where the end point is. That gives you the length of the given wire. It will be in what units? Centimeters. What do you have here? Centimeters. You have to convert it into meters. How do you convert centimeters into meters? By 100. So, I have written 10 power minus 2. So, keep it. So, you got average X, which is the resistance of the given wire. And L is the length of this one. Next is, what is the formula for our aim is to determine rho. What is rho? Specific resistance, or in other words, you call it as resistivity. Okay. This is the formula X into pi r square by L. L I have written there small l. Is anything. If I have written small l, you better write small l here. Anything you can write. Now, I have to determine R. What is R? What is R? Resistance. No, radius of this given wire. R is the radius of the given wire. Earlier I said here when I have started that R is the resistance. We use it for both purposes. So, depending upon the context, you must understand it. There, I have written that is the resistance per unit length of the meter bridge wire. Now, I am calling this R as the radius of the given wire. So, you have done screw gauge experiment. Did you or not? You have done screw gauge experiment. Screw gauge is used to determine the thickness of thin objects like your scale or any metal strip, glass strip like that. And also to determine the radius. So, in order to determine the radius of this given wire, initially you have to determine the diameter of it. Radius is equal to half of the diameter. So, I have drawn another tabular form here. Students, this is to determine the diameter and hence the radius. Initially, I need to determine the diameter. So, and above the tabular form, you can write, what do you write? Diameter of the given wire. Okay. So, this is the tabular form, serial number. What do you mean by PSR? Pitch scale reading. Pitch scale reading. What is OHSR? Observed head scale reading. See, main focusing is not on this in this experiment. Main focusing is on meter bridge. But you need to use screw gauge also. Then only you can go ahead. Otherwise, no way for us to determine R. So just take 3 readings. That will be enough, sufficient. So OHSR is observed head scale reading. Okay. Then what is EHSR? Corrected head scale reading. So before you start the experiment only, you first have to check whether your screw gauge has any error or not. Positive error or negative error. You must write that above the tabular form. Okay. Then suppose I have minus 20. Minus 20 as the error. Then the correction will be plus 20. So I have written, I have added 20. It becomes 60. 40 plus 20, 60. Then you can leave this. My concentration will be on this. 60 multiplied by the least count. What is the least count of a screw gauge? LC of screw gauge is 0.01 millimeters. Okay. So I have multiplied 60 by 0.01. I'll get 0.60. Okay. Now, this is A, pitch scale reading. Corrected head scale reading multiplied by least count is B. Diameter is A plus B. So, 0 plus 0.60 is again 0.60. Now, you keep the screw gauge at some other point. To be more and more accurate to take, we are taking number of readings. Okay, our reading should be perfect to the extent possible. So, you have taken 3 readings for diameter. Take the average of 3 readings. How do you take the average of 3 readings? Add the last column readings and divide by 3. That gives you average diameter. Average diameter. Average reading you should not say. Average reading of what? Average of mass, average of weight, average of density, average of volume. So you must write the full sentence. Average diameter of the given wire. Okay. Add all the 3, divide by 3. Then you'll get average diameter only. In what units you will get? Millimeters. We'll get it? Screw gauge, because you multiplied with millimeters now. Yeah. And your PSR also will be in millimeters. So, total reading in the last column will be in millimeters. So, diameter is in millimeters, length is in centimeters. You can't substitute like that in one formula. So, everything you convert. That's the reason why I converted the length also in meters. So, you convert the millimeters also into meters. How do you convert millimeters into meters? Into 10 power minus 3. 1 millimeter to centimeter, 10 power minus 1. Again, centimeter to meter, 10 power minus 2. So, on the whole, it will be to convert millimeters into meters, 10 power minus 3. So, average diameter you take by 2 gives you average radius. Multiply that by 10 power minus 3. Okay. So, you got X. Finally, our aim is to determine rho, the resistivity or the specific resistance. This is the formula, X into pi r square by L. X is the unknown resistance which you got here, average. Pi 22 by 7, 3.14. R is the radius which you determined from the above formula. L is the length of the given wire which you determined by using the scale. After substituting everything, you will get rho, the specific resistance of the material of the given wire. You can't get any value you like because specific resistance is unique. unique for each material. Okay. So that much more or less, because some experimental error will be taken into consideration. So you must get near the specified value of nichrome, then only you have done your experiment correctly. Okay. So finally its unit is ohm meter. Ohm meter. Okay. So this is how we are going to do meter bridge experiment to determine the specific resistance of the given wire. Okay. Now you have to take readings without parallax error, and the jockey should not be dragged. Okay. If you drag, what happens is actually this meter bridge wire is so chosen that it is of uniform area of cross section from starting point to the end point. Okay. So don't drag it like this, but test at various points and while determining the null point. Okay. So that is it. Now using the same meter bridge experiment, we are going to proceed further. Instead of one wire, where is this? Here. If you are given two wires whose resistances are unknown, we have to determine. That is the next part. We will continue it. So we have just completed how to find the specific resistance of the given wire. Now we are going to determine resistances of the two given wires. These are the two given wires for us. This we are calling it as R1 and this is R2, unknown resistances, two unknown resistances. So how we are going to determine? Initially, we are going to connect these two in series and then in parallel. Then we are going to determine the individual resistances. So there won't be absolutely no difference in our circuit. So first is the one wire, as we have done earlier. We are going to connect these in series like this. Series. This is called a series combination. And one end you connect here. One end is connected to one binding screw and the other end to the other one. Other one. So what do we call this combination? This combination we are going to call the series combination. The wires are connected. The starting point of the second wire is connected to the end of the first wire and those two are connected here. So like we have done earlier, using this jockey, you press at various points till you get what deflection in the galvanometer. You should get zero deflection in the galvanometer. When you are getting zero deflection in the galvanometer, either in this part or in the earlier experiment, the jockey is dividing the meter bridge wire into two parts. Listen carefully, not two halves, two parts. So that has become a Wheatstone bridge. How Wheatstone bridge? Where are the four resistances? This is one. Meter bridge resistance is another one. And from the starting point to where you are getting zero deflection, L1 is one part, okay, whose resistance is RL1 ohms, and the next part is RL2 ohms. So this has become a meter bridge. So like that, just by pressing at various points where you are getting zero deflection, you note down that length is L1 centimeters, like you have taken earlier. That I have written here. What is this combination? This is called resistances or wires. In what combination? Resistances in series. Resistances in series. Resistances in series. So you take, first you have taken 1 ohm, then 2 ohms, then 3 ohms. Just the same way you have done earlier. 3 ohms you take. The formula is also same, but we are calling it as not X this time. We are calling it as RS. Okay. So what is RS? We have learned the formula. When number of resistors are connected in series, the effective resistance is just the sum of individual resistances. So in the last column, what you are getting is not R1, not R2, but the sum of those two, which is called as RS. Okay? So keep that aside. Now, I'm taking the 2 wires. I'm taking out the 2 wires. We have to connect the same 2 wires in parallel. So, how do we connect parallel? This is the parallel combination. I'll show here. This is R1. This is R2. So, one end here, the other end here. Like this. So, this is how I'm connecting. Okay. So, this way you connect. Together you connect. So again, how much resistance I am including in the circuit? I am including 1 ohm resistance in the circuit. I am including 1 ohm resistance as you have done in the earlier cases. So test at various points till you get what deflection in the galvanometer? 0 deflection. And what is L1? In all these parts, what is L1 is? L1 is the length from the starting point of the meter bridge wire, this side, where unknown resistance wire is connected. This is L1, this is L2. So, if I get this as 71, 100 minus 21, 100 minus 21 is 79. That is 0.026. Like that, you take, apply 2 ohms, 3 ohms. Now, what I am getting is RP. What is that? How do you get, you have, when resistors are connected in parallel, 1 by RP is equal to effective resistance, 1 by R1 plus 1 by R2, like that. But you don't go to all these details, but that is RP you are getting. Okay. Now, our aim is to determine what? R1 and R2. So, this is the formula for R1. R1 is equal to RS plus square root of RS square minus 4RS RP by 2. Okay. Use this formula. RS is in the first tabular form. RP is in the second tabular form. Not the average of those. Add the 3, divide by 3, you will get that value, you take it. Now, for R2, actually you can use the formula RS minus etc. But that is not required. But you have a simpler formula. RS, the effective resistance. R1 plus R2. R1 you got. So what will be R2? RS minus R1. Okay. So this is how you are going to determine the resistances of the given 2 individual wires, unknown resistances of the given 2 wires R1 and R2. First by connecting them in series and then connecting them in how? By connecting them in parallel. Okay. So in examination you have 2 different questions on this meter bridge. They may ask you to find out the specific resistance of the given wire, what we have done earlier, or you will be asked find the individual resistances of the given 2 wires first by connecting them in series and then by connecting them in parallel. So if you are asked this part by connecting them in series and in parallel, you need not do the first part. Only this part will be enough by drawing these 2 tabular forms. Or if you are asked to find the specific resistance of the given wire, this part is not required. You do the first part. So read the question thoroughly and then do it. Thank you.